Okay, exclusion chromatography, the mechanism used for separating solid molecules according to their size or more accurately their volumes is called exclusion or size exclusion chromatography. The mechanism used for separating solid molecules according to their size or more accurately their volumes is called exclusion or size exclusion chromatography. Types of exclusion chromatography, gel permeation chromatography or gel filtration chromatography, and exclusion chromatography or ion retardation chromatography, inorganic molecular sieves. Gel permeation chromatography. Gel permeation chromatography is a type of size exclusion chromatography that separates, analyze on the basis of size, typically in organic solvents. This technique is often used for the analysis of polymers. Application of gel permeation chromatography. GPC is used for analysis of mixtures of different molecular weights. This technique is used in the separation of sugars, salts, amino acids, proteins. GPC is used in the separation of low molecular weights molecules from high molecular weights molecules. This technique is used to separate nucleic acids from nucleotides, polysaccharides from sugars. RNA and virus have been purified using agarose gel, and exclusion chromatography involves the use of strong anion or cation exchange resins for the separation of ionic solutes from weakly ionized or neutral solutes. Advantage of ion exclusion chromatography. Ion exclusion chromatography is cheaper than ion exchange as no regeneration is required. The process is simple and adaptable to continuous operation. The method is applicable to a wide range of materials. Disadvantage of ion exclusion chromatography. The resin must be in the same ionic form as the electrolyte in solution. Example, for passing sodium chloride, the resin must be in the sodium form. The technique permits separation of sugars and salt because of the size in relative inability of sucrose and glucose molecules to diffuse rapidly into the resin phase. Riemann used salt instead of water as a eluent and separated methanol, ethanol, and propanol. Application of ion exchange chromatography. The separation of strong electrolyte from neutral molecules can be best achieved by ion exclusion chromatography. For example, sodium chloride from ethylene glycol, hydrochloric acid from ethanoic acid, sodium chloride from ethanol can be separated. The technique is permits separation of sugar and salt because of the size and relative inability of sucrose and glucose molecules to diffuse rapidly into the resin phase. Riemann salt used instead of water as a eluent and separated methanol, ethanol, and propanol. Inorganic molecular shapes, the natural and synthetic crystalline materials, including zeolites, metal amino silicates, form molecular shapes, which can be used in the column to provide an excellent separation of small molecules from larger one. A typical molecular shape or zeolites has a general formula where M is cation of valency N. And retardation chromatography. And retardation is a column operation similar to ion exchange chromatography, but employs anion exchange resin containing both cationic and anionic functional groups with the resin matrix. The resin will absorb anions and cations from the sample solution. However, the absorption affinity is so weak that water can be used as regenerate. Ion retardation chromatography is different from ion exchange chromatography in that the ions are also retarded as they flow through the column. Ion retardation can affect or separation of electrolytes from non-electrolytes and also from other electrolytes if the distribution constants are sufficiently different. For example, ammonium chloride and zinc chloride, ammonium hydroxide and sodium hydroxide, ferrous sulfate and zinc sulfate, etc. can be easily separated by the ion retardation chromatography. Okay, it's all about exclusion chromatography. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. Let's now bye bye. See you again.